Okay, so let's get started. We're going to be taking a look at talking about the basics of our output control using our Motec M1 software. We need to make sure we're understanding what the various type of outputs we have in our programming can do in terms of both load syncing capability and then understanding when to choose a certain output type versus another. So we're going to be covering the terminology, both low and high side outputs in this tutorial. We're also going to be covering full bridge, half bridge type of outputs and taking a look at peak and hold outputs versus low side outputs. There are a lot of things to break down here, and just to get familiar with, this is not going to show you how to set up a specific output type. We're going to have that in future tutorials, but let's jump in here and take a look at understanding the fundamentals here of working with output programming so we know exactly what to expect when we're trying to control a particular circuit. So let's jump in here. I'm going to move from my tuning page in my workbook I provided for the training course and jump down here under setup, and we're going to move here into the all calibrate window. Here we're going to jump right in and take a look at programming an output so we can see the various choices that we have within the Motec control strategy, and then we're going to be breaking down what to expect for those output types and then when you can expect to use a particular output versus another. So let's move in here and take a look at coolant in our drop down and specifically in our fan. So this is going to be using an output from the Motec to turn a fan on or off, or even what's known as a pulse width modulated control. So there's going to be that functionality that we also have to break down here. So when we're talking about output control, we either have an on or off type of functionality. So to turn a circuit on or off, such as a cooling fan, let's say, for example, it's just a basic on-off type of control. We want the fan to come on at 190 degrees Fahrenheit, turn off at 180 degrees Fahrenheit. We can set that output up to do just that. Then we also have what's known as a pulse width modulated output. Instead of having just an on or an off type of control, we're going to be pulsing the output very quickly. In fact, we're programming what's known as a frequency for the output, and that's going to be how many pulses within a time frame, usually a second, we're going to be sending out to control the device. So we're going to have a duty cycle type of control, similar to a fuel injector, how we pulse a fuel injector to control a device. Now, that's going to depend on what kind of circuit we're dealing with, whether we choose an on-off type control or a pulse width modulated control. So for example here, for a cooling fan, we would either have a relay between the Motec and the fan, a basic on-off 30-40 amp relay, where we could tell the Motec to ground or power the relay, and then the relay would handle the load switching and turn on the power to the fan and turn on that device. And then when we wanted to turn off, we drop the output for the control to the relay, which then would turn that fan circuit off. You may have a fan that's pulse width modulated controlled. In that case, you can actually pulse the fan through a solid state relay or a fan control device, which is essentially a solid state relay, and you can vary the amount of duty cycles 0 to 100%, essentially feeding more or less current to the circuit, and again pulsing in a certain amount of pulses per time frame, which again usually a second, and that's going to be what's known as our frequency. So we have that kind of output programming capability with our Motec, so either an on-off or pulse width modulated. The next thing to know here in terms of our control would be both a low side or a high side output from the actual output we're choosing. So a low side output will send a ground out from the pin that we're selecting here in our output resource, and that'll go and ground the device. Now, we also have the capability to send what's known as a high side output, which is going to be sending then a 12 volt out from the output that we choose here. And the high side output is going to be specific to the actual output type that we're selecting, and we're going to talk about that here in just a second. Now, just to understand exactly what I'm talking about in terms of a low or a high side output, let's just look here real quickly at the schematic that I have coming up on screen. And this is going to break down the low side, high side type functionality, just so we can see what this looks like using a relay between our Motec and our cooling fan. Let's assume that fan pulls something like 30 amps, 20 amps, pulls a lot of amps, and we're not able to sync that through the Motec. We need to have that relay between the Motec and the fan to control it. So looking here at our schematic, we have one leg of the fan going to our chassis ground, so we're just grounding the fan. The other leg of the fan, other wire from the fan, is going to be a 12 volt. That's what we use to turn on that fan. We can see that the relay has numbers that are associated to the relay, so they'd be looking at the bottom of the relay. you'll find that there's an 87, a 30, an 86, and an 85. Those are the numbers you'll find on a standard relay. 87 would be the output from the relay, and that's going to send the 12 volt to the fan to turn that circuit on. 30 is going to be typically fed from our battery power source, so 12 volt in. So it comes into 30, comes out 87. Now inside of the relay, there's going to be an internal circuit with winding, and it's going to either turn on or off, essentially connecting 30 to 87 when it's energized. We'll find that in this case, 85 is going to be having a 12 volt key-on source fed into it. So it's going to be having being energized on one side of that solenoid winding inside the relay. And then 86 is going to be what we ground in a low side format with our Motec. So the Motec is sitting there, it's sending an output to the relay when we program and command it on, and that'll turn on that fan at whatever coolant temperature we'd like. So that's going to be the example of a low side. We're grounding the relay, and then therefore we're completing the circuit, and then we're transferring the power from 30 to 87 to the relay, fan turns on. Now, if we flip things around here a little bit, we can actually set this up so the same exact scenario, looking at the wiring and the relay numbers, if we actually go to 85 and we ground pin 85, but then we send power into 86, this would be known as a high side output. So we have both low side and high side.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.